Now before I stop and finally put a pause in this section, I would like to help you understand how did I draw. If you remember the graph in the very first lecture, like this. Now remember, I started with a problem in which a man was running and he ran 9 kilometers in 1 hour. And after the discussion of that problem, I drew two graphs of displacement versus time, one for the uniform motion and other for the non-uniform motion, in which I said the man was running, started slowly and gradually it picks up. He picks up in the mid region of his journey and then he gets tired and slows down. And I said this kind of graph fits for the situation. Now I'm going to help you understand how did I draw this graph straight away, just by saying you that, just by knowing the situation I drew the graph. Now how did I do it and what are my reasons for drawing this kind of graph? I'll tell you why. See, you already have learnt linear equations. Suppose there's a line like this. Now the general equation for this line will be y is equal to mx. Now this m can be anything depending upon the slope of this line. Like it could be y is equal to 2x, y is equal to 3x, y is equal to 4x, whatever it is, but it will always be of the form y is equal to mx. It will not carry a constant c, because this point of origin x is equal to 0 and y is equal to 0 have to lie on the curve, and if when you put x is equal to 0, this thing is 0. Now y will be equal to 0 only if this constant is 0. Okay, so for this kind of linear equation which passes through origin, the general equation is y is equal to mx. Now what this m is, that depends upon what the slope is. Now I'm using a word slope. You have to learn what this word is. Slope is defined, actually slope is the inclination of the line with x-axis. Suppose this angle is theta. Now slope is defined as tan theta. That's the definition of slope. Why? There are reasons, but for now slope is defined as tan theta. And tan theta, if we know basic trigonometry, tan theta is perpendicular upon base. Perpendicular is this, base is this, right? That means we are looking at this point. At this x, this is the y. I mean, suppose this is x1 and suppose this is y1, and this point is lying on the curve. So if I'm looking in this triangle, see this perpendicular is nothing but y1 and this base is actually x1. So this tan theta is y1 upon x1, and this point is lying on the graph, it's lying on the line, it's lying on the curve. So y1 and x1 must satisfy this equation, because this equation is the equation for the curve. So y1, if I put y1 and x1, now m will come out as y1 upon x1. Now tan theta is also y1 upon x1. So this m is nothing but slope. So slope is equal to m is equal to tan theta. Okay. Now see, I took a big triangle. Now let's suppose I'm taking a smaller one, a very small triangle, a very small triangle. Now such that the increment in x from this point to this point, the increment in x is infinitesimally small. So by extension, the increment in y will also be infinitesimally very small. Now I'm looking in a very small triangle, then and I'll draw a zoomed version of that. Actually it is like this. This angle, this angle here is angle theta, which is same as the angle theta that we took in the larger triangle, because if you come to think of it, these two angles are corresponding angles, so they have to be the same. So theta in this smaller triangle will be the same as the theta in this larger triangle. Like in this, the base that we took as x1 here would be dx, because it is infinitesimally small, so we will represent it as dx, and this height, this perpendicular which we took as y1 will be here dy, which will be infinitesimally small. The point here is slope, which is tan theta, which is m, which is actually perpendicular upon base, will be equal to dy upon dx. The slope will remain the same. The slope at this point is dy by dx. Suppose in this case it was a simple equation. In a complicated equation where it's not a linear equation, it's a non-linear equation, maybe the one like this. But if I have the mathematical equation between y and x, then slope at any point could be calculated as dy by dx. dy by dx is actually also the slope of the curve. And to calculate the slope on this was a straight line, so you take a larger triangle and you get the slope. But the curve, the one which is like this, at which every point it is changing its curvature, the slope actually is calculated at a particular point. You cannot take a point, a distance between origin and this to calculate the slope, because you are not having a straight line anywhere. The slope is changing at every point. So slope, you can code a value of slope only at a particular point. So let's take this point and we want to calculate the slope at this point. So slope can be calculated by small change in x and looking at what is the small change in y. Meaning we want to find what is dy by dx. That is the slope. Now to do that, I must take small change in x, very small as you can't see it, and a small change in y, and you make this triangle. Fine, you can see the triangle. You can't, because I have taken infinitesimally small x change in x and infinitesimally small change in y. That's why you're not able to look at the triangle. But this is a triangle. If I zoom it, then you'll be able to see the triangle. See, you have a triangle here. Actually this triangle is here, but it is so small that we are not able to see. But there's a triangle here with very small change in x and very small change in y. And this part is actually lying on the graph. It seems to be straight here, but this is so small that we are not able to see. See, Earth is a sphere, but at particular moment of time we are able to see a very small portion of it, and it seems to be flat. It is so small portion that we are not able to actually gauge the curvature of the Earth, and it seems flat. So similarly, even though the curvature is changing and it's not actually straight, it is curved, but for a very small section it will actually seem to be a straight line like this. So on a very infinitesimally small level, this still is going to be a straight line and we can still make a triangle.